Welcome back to the Stronger by Science podcast. My name is Eric Trexler. I am the special temporary primary host of the show. Today I am joined by a special guest. He is currently the permanent co-host, the guest co-host, I should say, of the show. His name is Greg Nuckols. We have a lot of great content for today's episode, but before we get into that, it is with great shame and humility that we beg for your support, and I'd like to present a number of ways you could provide that. You could like, rate, or subscribe to the show wherever you happen to get podcasts. You could go to strongerbyscience.com/newsletter and join our newsletter email list. You could go to strongerbyscience.com/coaching and check out our very talented, very experienced team of coaches for one-on-one virtual coaching services. You could use our discount code at bulksupplements.com. If you use the code SBSPOD, that gets you 5% off of your order. You could check out the Mass Research Review, which we publish every single month, reviewing important new studies in exercise and nutrition. Or you could check out Macro Factor, our diet app, which does have a free trial, so you can take it for a spin and see if you like it. Greg, road to the stage. How are things going?
Yeah, things are going pretty well. No new milestones this week. Nothing super exciting to report, at least in terms of numbers on the scale. But overall, things are still trending in a good trajectory. As I guess like a bit of more of a dietary update than anything. I'm trying a fun little experiment. And by experiment, I mean I got tired of meal prepping and actually investing time and effort into doing that. So what I'm doing with my diet now is basically the same macros as before, but replacing all of the things that actually took effort to prepare with just fruit. So now I'm just cooking up a big pan of chicken thighs, and that is all of my protein and fat. And yeah, some from like milk as well for my tea and coffee. But pretty much just chicken, like seasoned chicken thighs, and that's that. And then all of my carbs are coming from fruit, which is great. I love fruit, and yeah, I had previously been, taking time and effort to make good meals with the macro splits I want, trying to get veggies in and whatnot. And yeah, that takes time and effort when instead I could just get a huge bowl of strawberries or eat like 10 kiwis in a sitting. So that's much easier and quite frankly, much more delicious. Fruit is incredible. And so one very important thing to note about this little experiment is any relation to how Paul Saladino currently eats is purely coincidental. I didn't find out about this until I mentioned that I was going to start doing this in the Macro Factor Facebook group. Someone was like, oh, is that because that's how Paul Saladino eats? And that almost made me not want to do this because I didn't want anyone to make that mistake. Purely coincidental. My reasoning for it and his completely different. He is afraid that all other plants besides fruit are trying to kill him, and he's terrified of that. I just like eating fruit. So yeah.
Yeah, he's really big on the idea of plant defense chemicals.
Yeah. Which is very funny, because that's why plants are good for you.
It's also why they're delicious.
Yeah.
I mean, I love a good spicy meal. I love a nice caffeinated beverage. Yeah, so I'm glad that you clarified that, because that's going to make my life a lot easier fielding questions. Awesome. So on the road to Athens, just because of my lingering hip issue, which frustratingly, I was like, okay, hip hurts too much to do a lot of the lifting that I like. Maybe I'll try marathon running. Didn't really work out for that either. So the road to Athens has basically become the way I train to maintain some semblance of endurance and strength until I have rehabbed to the point where I can really effectively take structured endurance running head on again. Mm-hmm. And I'm very optimistic about that. It's not like I'm saying, oh, that's never going to happen. But yeah, for now, I'm just finding ways to exercise that allow me to continue making some form of fitness progress without exacerbating any symptoms with my hip. So yeah, a couple developments lately. I finally am like getting my skill set back for basketball. I mentioned the other day, I'm finally getting to a point where, depending on the pickup game that materializes, at first, like I hadn't touched a basketball in 15 years. I didn't belong on the court. It was a mess. But I'm finally getting to that point where I feel like I can really hold my own in the type of pickup game that I would like to play. So that's been fun. It just makes the cardio way more enjoyable when you're like, yes, I'm a contributing member of my team who's very, very valuable to our endeavor.
Yeah.
So that was fun. And then I finally got out on the paddleboard for the first session of the year. I kept waiting for it to warm up. And then the moment it got warm enough, I was super busy and just couldn't carve out the time for it. But this weekend, got out on the water, did some stand-up paddleboarding. It is a really, really fun and enjoyable way to do some leisurely cardio. I'm sure that once you get pretty skilled with it, you can get the heart rate up a little bit. For me, I'm just kind of paddling around, having fun, enjoying the sun, the fresh air, the social aspect of doing it with my girlfriend and things like that. But yeah, stand-up paddleboarding it's not super accessible. I recognize that. There's some cost involved. You also have to be near a suitable body of water. But if you have the opportunity to give it a shot, it's a lot of fun and very easy to pick up. Like, you might look at it and say like, oh, I don't know if I have the balance for it. You pick it up pretty quickly.
Good deal, man.
All right. So Feats of Strength, what do you got?
Yeah, so I've got one from the weightlifting world this week. So the European Weightlifting Championships were this past weekend, and Antonino Pizzolatto, who is a Italian weightlifter, he set a new world record for both the clean and jerk and the total in the 89 kilo class, and the clean and jerk was 217 kilos. So for our American listeners, that's 478 pounds at a body weight of 196. And the video will be linked in the show notes if you want to check it out. And I gotta say, it looked about as easy as one could expect a world record clean and jerk to look. So Antonino Pizzolatto has recently moved up in weight classes. He previously competed at 81 and 85. He's moved up to the 89s, immediately set the world record, and he really looks like he's coming into his own in this class. Like it looks like it suits him really well. In the European Championships, he set 11 kilo PRs for both the snatch and clean and jerk, 22 kilo PR total. So yeah, this seems to be a class that fits him really well. And since he just recently moved up, I would anticipate that he breaks his own record again pretty soon. So congrats to him.
All right, good stuff. Now, moving on to the content for today's episode, the first thing that we want to do is revisit a conversation from last episode. So I was presenting a little segment about some buffering supplements, and we took a little detour and talked about the role of acidosis, or this accumulation of excess protons, and how that directly might impact the progression or development of muscular fatigue during high intensity exercise. And we kind of reached a bit of an impasse where I said, let's hit the books. Let's go take a look at some research and revisit this topic. Rather than kind of speculate our way through it and try to make sense of it. But the root, just to kind of summarize where we got with that conversation, there's an interesting challenge with interpreting this literature, because there are different types of buffering strategies that have been tested within the context of various types of sprint work or resistance training. So those buffering strategies would include beta-alanine supplementation. As an extension of that, I think you could lump in anserine and carnosine supplementation, sodium bicarbonate supplementation, which is an extracellular rather than intracellular buffer, and also just good old-fashioned hyperventilation, which is certainly not supplementation at all, just breathing in a particular pattern. So what's interesting about these 3 different buffering strategies is theoretically, you could suggest that maybe they could impact fatigue through some other mechanism that's not directly related to buffering. But all 3 seem to work to some extent in the right context with high intensity exercise. And certainly the most parsimonious explanation would be that they are working through the mechanism that they all share, which is buffering these excess protons, delaying drops in pH, and delaying acidosis to some extent, theoretically delaying fatigue. So that's all very cohesive and straightforward. But the challenge is that, back in the day when we were, the tide turns slowly in research.
Yeah, I mean, there's a difference between when research started getting published and when people started becoming aware of it.
Right. I was going to say, like, when I was an undergrad, it was a very straightforward narrative, right?
Yeah.
Like, acidosis contributes to fatigue. It alters the way muscle fibers work. It alters their contractile function in a variety of different ways. That was kind of the undergrad level, pretty simple explanation. But already at that time, there were papers trickling out that were saying, I don't know if that's necessarily true. And the root of this confusion comes from, there were absolutely some early studies that made it seem without question that acidosis had a direct role, and not just direct, but a primary role in inducing and, driving the progression of fatigue during high intensity exercise. So there were really 2 kinds of research driving this idea. First was just a really simple correlation that obviously is observed very routinely. We're doing exercise that produces acidosis. And of course, as that acidosis gets more and more intense, we notice that fatigue gets more and more noteworthy. So there's this kind of clear correlation that as acidosis goes up and pH drops, we see a clear onset and progression of fatigue. So just at the surface level, that certainly drove this perspective. And then there was also very mechanistic in vitro work where they would expose isolated fibers to these low pH baths. And they would notice that a variety of different aspects of contractile function would get impaired from these low pH, very acidic baths. So you can absolutely find papers, and I'll link a couple in the show notes, where they go through all the different contractile processes and metabolic processes that can get messed up by bathing a muscle fiber in an acidic solution. So things that relate to calcium sensitivity, force production, sarcoplasmic reticulum handling of calcium, different energetic processes involved in excitation, contraction coupling, and the cross-bridge cycle. I'll link those in the show notes for anyone who wants to dig through them. But there is this mechanistic basis where you would say, yes, low pH, prevalence of a really acidic, or the presence, I should say, of a really acidic environment. This drives fatigue at the muscle fiber level. The challenge there is that people started to look into this a little bit deeper, and they noticed that the experimental conditions were not matching physiological conditions. So most notably, the pHs that were getting tested were often a little bit lower than physiological levels you would anticipate. So it was an exaggerated effect of acidosis. And also something that I didn't quite expect, temperature appears to be an important issue. A lot of these studies were just taking place in ambient temperature. But of course, the intramuscular temperature during high intensity exercise, all the heat that's being generated secondary to contraction and metabolism, they were noticing that these experiments are not being performed at physiological temperatures that are compatible with intense exercise. And when they started doing those studies, those mechanistic kind of single fiber studies where they say, well, let's do it at a temperature that mimics high intensity exercise, and let's do it at a pH that mimics high intensity exercise. All of a sudden, this really disastrous impact of acidosis and low pH was not impacting muscle function the way that it previously had been shown to. And so that's where the field just kind of started saying, well, that's uncomfortable, right? So we kind of reached that point in the episode last week where we said, okay, that is something that we cannot ignore, but it's also very odd that these buffering strategies seem to work. You know, if acidosis isn't driving fatigue, why are they working? And so at first I thought maybe we were missing something obvious, but I was really relieved to look at some of the more recent review papers. And a lot of them point out the same thing. They say, okay, so we can't really pin this all on low pH, but all these buffers, you know, several different types of buffers that work somewhat independently, they all seem to work. And that's weird. So there's definitely something going on here. And that's kind of where we left it. In this episode, I want to propose two areas that might give us some additional clarification, two different lines of research that might help us make sense of this. So first of all, there's one line of research that is looking at, you know, creating force and power with muscles. We talk about it being a neuromuscular process, right? So, of course, the muscle fibers themselves are doing things. That's where a lot of this acidosis research lives, is looking at individual fibers. But we can't forget that the neuromuscular system involves these neural inputs that are really critical to actually making muscles work, right? And so that involves the nerves that send messages down to the muscle to contract, but also the nervous system is responsible for gathering information, you know, from the periphery and relaying that to more central structures that dictate some of those outgoing neural messages for contraction. So I am going to link a paper in the show notes that focuses specifically on what they call metabonociceptors, which respond to things like high lactate, high ATP levels, excess protons, or you know, the development of acidosis. There are these afferent signals basically that come back into the nervous system, particularly during high intensity exercise where there's a lot of lactate, a lot of protons, and there is a reasonably convincing amount of evidence suggesting that it's very possible that when muscles are doing this high intensity activity and we are seeing this acidosis developing, the acidosis might not be, you know, catastrophically impacting the actual contractile function of the fiber itself, but it might be sending signals back to the nervous system that the nervous system, of course, is responding to, saying, hey, shit hurts down there. Things are going pretty intense. We're making a lot of energy very quickly, which of course is a threatening thing to any living organism. So the idea is that there is some kind of complex communication going on with these receptors and the nervous system that is potentially contributing to fatigue, but from more neurally mediated centers. And the idea is that the muscle fibers themselves can still work in that pH, but upstream there are nervous, signals from the nervous system telling the muscle, I know you can work, but maybe don't.
Like some like central governor hypothesis stuff.
Yeah. So the idea is that the nervous system is basically decreasing some of that motor neuron firing to reduce muscle output due to fatigue that is being sensed at the central level in response to peripheral metabolite accumulation. That's the one area that I think might help us understand what might be going on here. So it's a lot more complex than just putting a muscle fiber in a bath.
Yeah. That's basically what I threw out as just a wild guess before we started recording.
Yeah, that is true. Now, that's, like I said, there's two lines of research I find really interesting. That's one of them. I think it's very compelling. If I had to put my money on one, I'd say that probably explains most of the confusion involved with acidosis, fatigue, and buffers as ergogenic ingredients. There is also some research that I'll put in the show notes where they specifically were looking at the independent effect. This was back to very mechanistic in vitro stuff with isolated fibers. So what they were looking at is the independent effect of elevated pH, elevated proton concentration or reduced pH, acidosis basically. They were looking at the independent effect of acidosis, the independent effect of inorganic phosphate accumulation, which you mentioned last episode, and then the combined effect of the two of them at varying temperature levels and in varying muscle fiber types. And of course, as you can gather from that explanation of the study, the results, very nitty gritty, hard science stuff going on here. But the very simplified result kind of summary is that the collective, the combined effect of having low pH and a lot of inorganic phosphate had a much bigger effect on force and power output of the muscle fiber than either aspect individually. And that effect was most pronounced at lower temperatures, but still persisted at temperatures that replicate physiological exercise-like temperatures. It was exaggerated in type 2 fibers, more so than type 1 fibers. And like I said, that combined effect was much larger than the independent effect of either one. There seems to be some degree of synergy there. So I think inorganic phosphate definitely still, if I had to put my finger on one metabolite that is likely to be directly driving fatigue, I would still put it on inorganic phosphate. But it does seem like there is a synergistic relationship by which the acidosis that develops during fatigue and high intensity exercise, that is kind of working with inorganic phosphate to produce this progression of fatigue during high intensity exercise. So it looks like, you could look at the more neural route and get some explanations. You can look at some of these more sophisticated, updated in vitro studies that have built upon some of these revelations related to acidosis and temperature. There is a narrative that is coming together, and you can start to see some of the aspects of how we will eventually understand fatigue progression during very high intensity glycolytic exercise. There's enough here to say, I think we're starting to notice the main characters of the story a little bit, but there's still some work to do to put together the relative contributions of how this all fits together. But at the very least, I don't think we're in a position where we say buffers work, but it makes no sense at all why.
Yeah. But
But I think we are at a position where we say buffers work, but it's a hell of a lot more complicated than just saying if you can keep, buffering protons a little better, fatigue will be delayed in perpetuity. There's a lot more that seems to be going on here with fatigue. It looks like buffering some of those protons can be helpful, but the story with muscle fatigue is very, very complicated, and there's a lot of moving parts there. So hopefully this provides a little bit of clarity related to our previous segment, and hopefully, my God, I hope this is just one additional little anecdote that leads you to be a little more skeptical of content creators who just take a mechanism and run with it.
Yeah.
And just kind of speculate and speculate and speculate based on mechanisms, because you can only speculate on a mechanism that and derive actionable kind of practical takeaways if you assume that we already know everything about the processes involved and that there will be absolutely no downstream effects you haven't accounted for and no other moving pieces that you haven't accounted for. So we've talked in past shows about, where we fit on the spectrum between, how much you rely on mechanisms and theory, how much you rely on empirical data. I think we both tend to rely a lot on empirical data whenever it's available, because this is just one additional instance where stuff gets complicated in the body. And there are a lot of processes where there are overlapping mechanisms and redundant mechanisms and synergistic mechanisms, and most notably mechanisms that we don't know about yet.
Yeah.
And so trying to take mechanisms and just say, oh yeah, I have a perfect series of strategies to exploit that. It can be done sometimes, but it gets messy.
Yeah. I do think that there's a general tendency for people, I was going to say people outside of science, but even people in science, to overestimate how much we already know about the body and how it works, when, like, I don't know, like, I think that largely relates to, like, maybe people looking at the history of science and medicine in particular, and looking at the rate of progress that we made on stuff from, basically, like, maybe the interwar period until the 70s. And it seems like the rate of progress is slowing down a little bit. And so I think then the natural implication is like, oh, well, maybe we've basically learned the vast majority of what there is to know about the body. And so, like, if someone's talking about mechanisms, they're talking about a variable in a solved problem. When, like, that really just isn't the case. Like, I think one of the best examples of that was, like, not even that long ago, maybe like 2014, 2015, scientists discovered the lymphatic system in the central nervous system, now termed the glymphatic system. And, like, it's a shitload of lymphatic tissue, and they just hadn't found it before.
Yeah.
And so, like, that completely like revolutionizes our understanding of how things can flow into and out of the brain and what might be able to affect the central nervous system that we were unaware of before. It's, like, truly revolutionary finding. And yeah, like, we were just, like, completely in the dark about it until, like, 7 years ago. So yeah, and that's, that's like macro scale stuff. That's stuff you can learn via dissection. In terms of like every little thing that's going on in each muscle fiber, like, no, we're still, like, we certainly know the way science progresses. Like, we know more this year than last year. We know more now. We know a lot more now than we did 10 years ago, and we certainly know a lot more than 100 years ago. But yeah, there's still so much left to learn.
Yeah, no, it's true. I mean, it's something that can be very humbling is when you study exercise science and then someone asks you a question that, like, they assume, like, surely you guys have worked that out to a very clear understanding and a universal consensus.
Yeah.
But you start getting questions about stuff. We're not talking about, like, questions that are just, very elaborate, specific, unique circumstances. It's just like, hey, what's up with cramps?
Yeah. Well, my go-to is just like, oh, what's the best way to train in a calorie deficit? Like, should I keep the volume high or keep the intensity high? People don't believe me when I tell them this. There's no research on that.
Yeah.
Like, there aren't any, like, direct RCTs comparing one approach versus the other, which is crazy, because that is, like, just a very basic thing. And yeah, it's not that there are some studies that could be better. There's just not research on it.
Yeah. Yeah. And then there's other areas, like I said, where there's research, but there's still, like, competing theories that have not been stifled. And, there hasn't been, like, a very, very universal scientific consensus. And, like, we're talking about research right now on fatigue. You would think that, like, with exercise, you're like, what's one of the first things that we should sort out?
That is where our whole field started.
Correct. Yeah, the fatigue lab.
Yeah, the Harvard fatigue lab.
Yeah.
That's because the whole point of exercise science initially was just, how can we make soldiers better? Because military funding was that during the interwar years, or was that post World War II? But whatever, it doesn't matter. But, like, that was the whole point. Like, we want our soldiers to be able to go longer and fatigue less on the battlefield than the people we're fighting against. So, like, the military just gave a ton of money to Harvard, and they're like, figure out how fatigue works, because, we think that will give us an advantage in war. So, like, that's where our entire field started.
Yeah.
And yeah, we don't even have a full picture of fatigue yet.
Right. Yeah. It's crazy. All right, so hopefully that cleared some things up and made people far less confident in everything they've ever thought about the things they do. So next up, you've got a couple segments. I think it's probably best to let you intro them yourself.
Yeah, so I've got, first one, I've got an article discussion segment. So we recently published an article titled "Where Are All of the Female Participants in Strength, Hypertrophy, and Supplement Research?" This was a what are we calling them again? What's the name for this type of article?
A cover story?
A cover story, yeah. So we're starting something new with Mass, where we publish a cover story each month. Just kind of like when you go to a grocery store and you see the magazines on the stands, and it's a magazine, has a ton of content in it, but they're going to lead with a cover story to kind of draw you in, entice you to check it out. So we're going to start going that route with Mass, and we're going to be publishing the cover stories on Stronger by Science. So be on the lookout for that the first of each month. And our first cover story was one by yours truly. And so I was interested primarily in the extent to which female subjects are understudied and underrepresented in the sorts of research that the Stronger by Science article or the Stronger by Science audience cares about. So, strength research, hypertrophy research, body comp research, supplement research, mostly related to resistance training. And this was so part of the problem was that there have been prior attempts to quantify male versus female research participation in exercise science generally. So the title of my article is actually an homage to a 2014 study by Costello and colleagues that was looking at this question. But again, it was just looking at just kind of exercise science generally. So what Costello and colleagues did is they looked at all of the research published in 3 of the major journals in our field, Medicine and Science and Sport and Exercise, British Journal of Sports Medicine, and American Journal of Sports Medicine for a 3-year period, so from 2011 to 2013. And, just pulling up all of the articles published in those 3 journals for that 3-year span, and just counting up, how many total male subjects were there in all of these articles? How many total female subjects were there in all of these articles? And what they found was that the total subject pool was about 39% female and 61% male. But that is of limited utility for us. Primarily because there's a ton of research in our field that is not at all related to resistance training. So those journals are going to have a lot of stuff about rehab. They're going to have a lot of stuff about injuries. They're going to have a lot of stuff about aerobic training. They have a lot of stuff about just kind of general public healthy type research.
What a waste.
I mean, it's good stuff, but it's not directly relevant.
It won't make you stronger.
Correct.
Which is a waste.
Exactly. And so, basically it found there was about a 60-40 split. And my hunch was that wasn't quite right for resistance training related research. Something we've noticed when writing Mass articles in the past is we'll stumble into an area of research that has 15 studies that are just all on men, or there's 12 studies on men and 1 on women. And so I was always thinking 60-40 would be nice, but I think it's worse than that for resistance training research. And one of the other things that put me further down that road is there was an article published in Science News by a journalist who also happens to have a PhD in physiology and pharmacology named Bethany Brookshire, who basically took a really similar approach to Costello and colleagues, but instead of just simply giving the numbers, she broke it down by research area. And so what she found is that when you kind of categorize by types of research, splitting things out into metabolism-based research, disease-based research, basic physiology research, research looking into the social aspects of exercise, research looking at sports injury, and research looking specifically at performance. So when you split things out like that, research related to everything but performance seems to have something approaching an equitable split. So anything from 40% female, 60% male to 60% female, 40% male, like things are looking pretty good. And then for the performance studies in particular, there was one study that had 90,000 subjects looking at marathon pacing strategy that had a fair number of female subjects in it, but that was also the majority of the total subjects in those performance related studies. So when you just exclude that one study that kind of had undue weight on the analysis, the performance related studies in the journals that she looked at, only 3% of the subjects were female, which that seemed too low to me based on the research I'd been reading, but it at least gave me a further inkling that, at least for the research that we're the most interested in, there's probably fewer than approximately 40% female subjects. So yeah, I wanted to look into that, and I wasn't interested in just characterizing the ratios of male and female subjects in the research we care about. I also wanted to see how trends were shifting over time. So, is it a scenario where there were way more male than female subjects in the research in, say, the 90s and 2000s, but it's trending towards being more equitable now, or the other direction? And I also wanted to get a rough idea of the degree to which this matters. So I think I'll talk about that with a bit more nuance later, but essentially, if there is a scenario where female lifters are quite underrepresented in the research now, I wanted to get a decent idea of, well, okay, given that set of circumstances, how confident can we be in generalizing research on male subjects to female populations, and also vice versa? And this is something that comes up a lot as someone who talks about science on the internet. If I share a study where all of the subjects are male, I'll generally get a comment or two from women, very understandably so, being like, hey, all of these subjects are male. I don't know if this research will apply to me or generalize to me. And vice versa, but much more extreme. If we share a study where the subjects are female, there will always be like half a dozen angry dudes in the comments being like, the subjects are women. Like, this doesn't apply to me. This is dumb. Why did you share this?
And it gets exponentially worse after menopause.
Correct.
I noticed that if you
God.
publish a study on postmenopausal women, those comments go through the roof.
Yeah.
For sure.
Which those annoy me more than anything, because like it seems like the assumption is that postmenopausal women basically don't exist, and so why should you talk about them? And it's like, I gotta tell you, man, half the population are women. They will all become postmenopausal at some point, and there are postmenopausal women in our audience. So like, whatever, deal with it. So yeah, I was interested in that as well. And so the strategy I devised to attempt to tackle this question is to basically let meta-analyses do a lot of the heavy lifting for me. So I wanted to find a representative sample of recent systematic reviews and meta-analyses in our field and kind of mine them for characteristics of the studies that were included in those systematic reviews and meta-analyses. Because most review papers like that will have a table, generally it's table 2, that just gives a rundown of what studies were included in the systematic review or meta-analysis. What were the subject characteristics, how many subjects were there. And so that accomplishes a couple purposes for me. One is I was writing this on a deadline, and, basically I could look at about 40 systematic reviews and meta-analyses and bring in data about 600 plus individual studies. Whereas if I looked at all 600 of those individual studies one by one, coded them myself, it would have, instead of being a pretty intensive 2-week process, it would have been a pretty intensive 2-month process, which I simply didn't have time for. And 2, systematic reviews and meta-analyses do start with a systematic literature search. And so I wanted to ensure that I wasn't getting a biased sample of research to base my analysis on. And so, other people were already doing unbiased systematic searches. So I felt pretty good about leaning on them to pull in representative papers. I pulled in an initial pool of 45 systematic reviews and meta-analyses. There's a page on Stronger by Science where we just kind of like keep a running list of all of the relevant systematic reviews and metas being published in our field. And I just kind of went down that and I tried to find basically all of the recent ones on things that we get asked about pretty often, to get a representative sample of the research that you guys care about. And then from there, I just looked into them, extracted all of the relevant information, and went on with my analysis. All of the details about my specific methodology, you can find them in the article, which will be linked in the show notes. Let's get into the results. So what I found is dealing with a total sample of 628 unique studies. 65% of them, so 408 out of the 268, used male-only cohorts. 133, or about 21%, used mixed-sex samples, and 73, or only about 12%, used female-only cohorts. And 14 of the studies, or about 2%, did not specify the sex of the subjects they used in their study. In terms of trends shifting over time, basically what I found is that from the 90s on, the proportion of studies that use mixed-sex cohorts has basically been flat. It's been about 20% of studies every decade since the 90s. But what I also found is that the proportion of studies that use female-only cohorts has actually been going down, and the proportion of studies that use male-only cohorts has been going up. So the relative representation of female subjects in this area of research, contrary to what I assumed, is actually getting worse over time, which I didn't love seeing. And then, like I mentioned, I wanted to get a rough idea of how generalizable research was between studies on male samples and studies on female samples. And so this was a very quick and dirty way to do this analysis, but it was really, I think, the only feasible way to do it. So what I did is, for all of the metas I looked at that had forest plots, what I would do is look at the effect estimates from studies with female-only cohorts and look to see if the 95% confidence intervals of those effect estimates overlapped with the 95% confidence interval of the pooled effect estimate for like the full analysis. And so that, like I said, is a quick and dirty way of looking at it. So, if you have a wide confidence interval, you could have mean effect estimates that differ quite a bit while the confidence intervals still overlap. Confidence intervals overlapping doesn't necessarily mean that two things aren't significantly different in terms of like statistical significance. And like the ideal way to go about doing this analysis would just be to recreate metas for all of these things. Like for each one of the metas that have been published, recode everything, perform a meta-analysis on the male-only studies, perform a meta-analysis on the mixed-sex cohorts, perform a meta-analysis on the female-only studies, and then compare those pooled effect estimates. But that would have involved doing 201 individual meta-analyses, which I don't have time for, and quite frankly, I don't think anyone has time for.
You could have just emailed the authors of the original papers and done a participant level meta-analysis with individual data.
That would have been even better.
That's what I would have done personally, but Anyway, go on.
But yeah, so if I went that route, we want to be talking about a 2-week project or a 2-month project or even a 2-year project. That would be a career spanning project. Which I just wasn't going to do. But yeah, so just looking to see if confidence intervals overlap. That's again, it's a very quick and dirty way to assess this. But what I found is that of the 185 effect estimates from female-only studies across 67 forest plots, those confidence intervals overlapped with the confidence intervals of the pooled effect estimates almost 95% of the time, so 94.6% of the time, which is... So you can't take that as evidence that studies on male and female cohorts get the exact same responses, but that is reasonably strong evidence that at least like the responses aren't night and day different most of the time. So you can't assume that results will generalize perfectly, but your a priori assumption should be that they most of the time generalize pretty well. So yeah, that's what I found. And just getting into my takeaways from this, at least. So the first one, well, I mean, really my biggest takeaway is just that there should be a lot more research that uses mixed-sex samples. Most of the time, results in male and female subjects aren't that different. So using a mixed-sex cohort has a couple advantages. One is it would simply make recruitment a lot easier. If you're now recruiting from the entire human population instead of half of the human population, it should be easier to recruit more subjects. A lot of the times, recruitment is the hardest part of doing research, like especially if you're doing a reasonably large study. Recruitment can be like pulling teeth. So making recruitment easier in in any way that is justifiable will just make science work better. And two, it will generally make more results more generalizable, and you can have more confidence in the generalizability of your results, which is also a good thing. The biggest piece of criticism I've gotten about this piece that I would like to address, because I was going to say, in my opinion, it's not valid criticism, but it's not just my opinion. This is completely invalid criticism. There were people who would comment, like when we shared this on Instagram or Facebook or wherever, be like, well, Greg, you're a stupid idiot here. Female subjects aren't being underrepresented in the research. The only reason that there are fewer female subjects than male subjects is you're interested in resistance training research, and there's just way more men than women who are doing resistance training. And, therefore, this is about what you should expect. And that's a really dumb criticism, because 65% of these studies used male-only cohorts. And so what that means is that being female was an exclusion criterion, which means that if a woman wanted to participate in those studies, she fucking couldn't. So if we lived in a world where all of this research used mixed-sex cohorts, and you still saw... actually, I forgot to mention one of the most important findings. So I talked about the breakdown of individual studies. In terms of just total participants, I found that 75% of the subjects were male, 25% were female. So big headline finding, completely forgot to mention. Anyway, going back to what I was talking about. So if we lived in a world where all of these studies used mixed-sex cohorts and we saw that same breakdown of participants, they're all mixed-sex. The researchers are trying to recruit both males and females, and they're still getting 75% males, 25% females, then you could say, okay, maybe the women aren't being underrepresented, and you're just seeing a reflection of general interest in resistance training and, by extension, participating in research related to resistance training. That's not the fucking world we live in. When women can't participate in 2/3 of the studies, you can't say that they're not participating in these studies because they don't want to. They're not participating in these studies because they're not allowed to participate in these studies. So I just want to make that very clear. I strongly suspect that the people who were making those comments saw the topic of the article and just immediately jumped to conclusions. If you actually read the article, it should be pretty clear why things are the way they are. But
that argument also kind of breaks down because it seems like the argument is because more men, a higher proportion, are already engaged in resistance training, they are voluntarily participating in these studies.
Correct.
I mean, a lot of studies are on people who are explicitly untrained.
That is also true.
Like, if you train, you cannot do this study.
Yes, that is true as well. I mean, most of the studies are on untrained people, and most of the subjects are undergrad, and most of the subjects participate either because they're getting paid $20, which is a lot of money to an undergrad student, or they're getting like 5 points of extra credit in a class. And I'm pretty sure women like extra credit just as much as men.
Yeah.
So yeah, I mean, even barring different levels of interest and participation in resistance training, yeah, that critique breaks down just in the real world, given how recruitment for most of these studies works in the first place. But yeah, so to take that criticism seriously, which I'll note, not doing after the fact, what I'm about to tell you, this is in the fucking article, and you would know this if you read it. So I was interested in, okay, how would things look if participation in research did scale with interest in resistance training? And so I found a paper that was a systematic review. It doesn't call itself a systematic review, but it was. But it was looking at, within countries that have data on this, what proportion of the adult populations, of the male and female adult populations, meet guidelines, like meet government guidelines for adequate participation in resistance training and general muscle strengthening activities. And so it varies country to country, but the overall picture you get is that the population of people who do meet government's resistance training guidelines, about 40% of them are women and about 60% are men. So, the current proportion in research, 75% male subjects, 25% female subjects, even if your a priori assumption is that we shouldn't be aiming for 50-50, we should be aiming for proportions that match participation in the general population, then we should still be shooting for about 60-40, which is a long way from 75-25. So yeah, that is what I found. And like I said, my biggest takeaway is just that way more research should use mixed sex cohorts. Like it very rarely comes with downsides, and it does come with pretty clear upsides. And one of the things that is also worth mentioning that I should have covered in the article, but I didn't, is I think the article may give the impression that the current state of things is fine, actually, because when you look at the forest plots, confidence intervals overlap most of the time. Research on males usually generalizes pretty well to females. So, why does this matter in the first place? Why should we want more female participants in these studies? And so I did do a poor job of making this clear in the article, but I think one of the primary reasons is that there is a difference between these two things don't seem to be super different, and these two things are exactly the same. Like those are two very different statements, two very different sentiments. And at this point, I suspect there are true sex differences that do exist that we currently don't have the statistical power to detect, because essentially we don't have enough research to adequately estimate sex-specific effect estimates. So, just to give an example of that, let's say there's a great example of this is research on training volume. So there are a ton of studies with exclusively male subjects that look at the dose-response relationship between training volume and muscle hypertrophy. And there are I think there are only 1 or 2 studies on female cohorts looking at the same thing. And so when you look at those 2 bodies of literature, they generally find the same thing, that to a point, higher training volumes tend to result in more muscle growth. But there's so little research on female subjects. We're nowhere close to being able to sketch what the dose response relationship for female subjects might look like. Like we can start to do a decent job of that with male subjects because there's enough research, but we just have no fucking idea what that dose response curve for female subjects looks like. And so it could be very similar, but not identical. Like, let's just assume that the ideal level of training volume on average for men is, say, 15 sets a week. It could be 18 sets a week, 20 sets a week for women. Like, I don't know if that's the case, but it could be. But the thing is, like, you're not going to have enough statistical power to estimate that with enough precision to know that those, like, that 3 to 5 set difference is a true difference, rather than just, a single estimate from a single study that needs confirmation. So, there very well probably are some differences that exist that we simply can't know about because there's not enough research on female subjects to estimate with any reasonable amount of precision how much those effect estimates differ. So yeah, like in general, this stuff seems to, like most research in our field seems to generalize between the sexes pretty well. But it probably doesn't generalize perfectly. And there's currently no way to know what areas of research male and female lifters are like very, very similar, virtually identical, and what areas of research maybe there is a trivial to moderate difference. Like in the Cohen's D family, like effect size differences in the 0.1 to 0.5 range. Like we don't have enough statistical power to know if differences of that magnitude, which are non-zero differences, not night and day differences, but differences that are probably large enough to actually make a difference in terms of training recommendations. We simply don't have the data to know if differences of that magnitude exist, and if so, what areas of research those differences exist in. And we need more research on female subjects to be able to estimate that with adequate precision to uncover those differences.
So, boiling this down to kind of summary bullet points here. Basically, you did a meta-analysis or a survey of meta-analyses on this topic. You found that female participants are currently underrepresented in the research.
Very underrepresented.
Very underrepresented, and it seems to be trending the wrong direction, getting worse over time.
Correct.
Current indicators suggest that there's not a massive, aggregated night and day difference to suggest that no male findings will generalize to female participants. However...
Well, I wouldn't even say that. I would say we can be pretty confident that they generalize quite well most of the time. But we can't be confident that they generalize perfectly, that there's like a one-to-one relationship.
And we need more female research. This is important because it's going to allow us to determine where some of those small to moderate size sex differences are that actually could be acted upon in terms of programming, nutrition, etc.
Yeah.
All right. Good stuff. So are you comfortable pushing your tech support segment, or would you like to get that in? Because we're like at an hour.
Yeah, we can push it. That's fine.
Cool. Because I do want to briefly cover HIIT, high intensity interval training, and then we'll wrap up the episode.
Sounds good.
So I've been teasing this Coach's Corner segment on HIIT for a long time. It's going to be very brief and to the point. But basically, a few episodes ago, a couple maybe, I mentioned that there's this kind of pervasive misconception that in order to do high intensity interval training, it has to be maximal intensity. You know, I've seen people literally saying if you're doing HIIT, your work intervals cannot be more than 30 seconds by definition. When you finish each sprint, you should feel like you're about to puke. And if you can do a HIIT session that's over 15 minutes, you're not doing HIIT anymore. So those are common perspectives. They simply are not compatible with the way high intensity interval training is defined in the literature, and not compatible with how high intensity interval training is studied in the literature. So what's really funny about that is some of these same individuals who are putting out content that reinforces this misconception, when you ask them to describe HIIT, they give you that definition. And then when you say, well, what's so good about HIIT anyway? They tell you about results from completely different interventions that don't meet their definition for HIIT, which is a little bit ironic. But anyway, you can kind of generally break down cardio into 4 different categories. You've got low intensity steady state. And so that's usually you're going to find that your heart rate is somewhere between 50 to 69% of max heart rate. And you can get into all sorts of discussions about the best way to determine max heart rate. I suppose they're interesting discussions if you're into it, but there's a bunch of different equations, or you could just test it, you know, do a maximal aerobic test. But anyway, 50 to 69%, you're usually going to call that low intensity cardio. And that's usually going to be done steady state because frankly, there's not much of a need to have rest intervals when you're keeping intensity that low. Moderate intensity steady state usually is going to be around 70 to 84% of maximum heart rate. Theoretically, you could do a steady state bout at a much higher intensity, but it's going to be a relatively inefficient way to do exercise because you're going to do one go and really tire out, and that's going to be the end of your workout. So usually with moderate intensity steady state exercise, it's going to be more of a prolonged exercise session so you can really get a decent volume of work in. Now, high intensity interval training, usually you're going to see work bouts that are at least 85% of max heart rate. And you're going to see, kind of switching back and forth between work intervals, which are the high intensity intervals, and then rest intervals, which either involve low intensity exercise or just passive rest, right? So you might do a sprint on a bicycle and as your work interval, and then during the rest period, just kind of pedal very lightly and just kind of recover, or you might take your feet off the pedals altogether. It's kind of up to your preference. A cautionary note, it can be very jarring to do super high intense sprints with passive rest periods that are short. Sometimes it's very nice to have some active recovery to kind of get some of those metabolites circulating. So sometimes people assume that the passive rest rather than the low activity rest is going to be easier. Sometimes it can be very nauseating if you're doing really intense intervals.
Yeah.
Now that brings me to the final one, which is sprint interval training. And this is the kind of subtype of high intensity interval training that a lot of people think is the only type of high intensity interval training. This is where you are doing maximal intensity work intervals. So the work interval will be a sprint at the highest attainable intensity, and then you're going to have low intensity periods as well with active or passive recovery. So sprint interval training is a lot like back in the day when bodybuilders like 2012, 2013 got really into modified wind gates as a cardio modality. And what they would do is like a 15 or a 30-second sprint on the bike, and then, a minute or 90 seconds or 2 minutes of rest, and just kind of repeat through these extremely high intensity, maximal intensity sprints on the bike. So that is sprint interval training, which could be viewed as a subtype of high intensity interval training. But what's really interesting is a lot of the common HIIT protocols in the literature, they actually involve 4-minute work bouts, which a lot of people I think would assume doesn't even meet the criteria for high intensity interval training. And it doesn't just meet the criteria. It's one of the most common protocols you see in the literature. So a really common protocol is 4 minutes of work, aiming to get above 85% of max heart rate, and then 4 minutes of, either active or passive rest. Usually it's going to be active rest when you have a 4 minute, it's usually 3 or 4 minutes for the rest interval. So usually people will do 4 rounds of that. So it'll be 4-minute work intervals. And then between those, you have 3 or 4 minutes of active rest. But there are also a variety of different protocols that involve 1-minute work intervals, 2-minute, 3-minute, 4-minute, and some as short as 30 seconds. And you'll see sprint interval training where you see really, really rapid sprints. We're talking 6, 10, 15 seconds long of just super high intensity effort. So the span of what you could generally call either sprint interval training or high intensity interval training, we're talking about sprints from 6 seconds long up to work intervals that are 4 minutes long. And usually, generally speaking, if I'm doing a HIIT or a sit workout, I try to make the total duration of the session somewhere between 15 and 25 minutes. If you're doing that and you've got a sensible work to rest ratio, between your two intervals, that's probably going to put you in a spot where you're able to get enough, total work in, enough total volume to feel like you got a nice session, but you don't want to go overboard with high intensity interval training. So for me personally, if I'm doing high intensity interval training, I try to do 15 to 25 total minutes, and I try to keep my work to rest ratio somewhere around 1-to-1. So my favorite protocol by far is 1 minute of very high intensity, 1 minute of active rest, and I'll do 10 rounds of that. So it ends up being about 19, 20 minutes. That's kind of right in the sweet spot, 1-to-1 ratio, work to rest. If I'm doing sprint interval training, again, I try to keep it to 15 to 25 minutes, but usually because it is maximal intensity, you see that the work to rest ratio actually goes down. So instead of being 1 part work and 1 part rest, usually it's 1-to-3 or even 1-to-8 when you start to see really short sprints. But yeah, so somewhere in that ballpark of 1-to-3 to 1-to-8 for your work to rest ratio. Of course, all of those sprints, whether it's going to be 6 seconds or 15 or 30 seconds, usually that's kind of the range. You don't see a lot of sprint interval training with durations that are too high above 30 seconds, maybe a minute, but that's pretty much where it kind of caps. But yeah, so you want to make sure that you're getting a proper work to rest ratio, keeping your total duration. I would start out in the 15 to 25 minute range. And there are a lot of different ways to incorporate, high intensity interval training, even if you don't like the super intense sprint type workouts. So this is something that's very accessible. I'm linking a paper in the show notes that specifically is looking at high intensity interval training for clinical populations. And so I forget exactly, I think they're looking at the health benefits and care related to cardiac diseases. So like I kind of dislike when people put out the narrative that high intensity interval training is only for elite high level athletes, because high intensity interval training can yield some really important health benefits that could help out a lot of clinical populations who should be able to incorporate this type of exercise as long as they are at an appropriate health and fitness level. So you don't want to just go straight in from fully sedentary with a clinical condition to sprint interval training without some kind of medical clearance. You want to make sure that you're generally prepared for that type of exercise. But I'll link a paper in the show notes that talks a little bit about the readiness to take on this type of high intensity stuff. But you'll also find for clinical populations that some of these high intensity interval training protocols, they start with really modest work intervals, because it's all about building up that kind of physiological base for the higher intensity work. So it's still high intensity in a relative perspective, but not yet in an absolute perspective, because they have to build up that base of cardiorespiratory endurance. So it should be a very accessible type of exercise. And even if you don't hit that definition criteria of 85% of max heart rate, you can still incorporate intervals when you're just getting into cardio. So like, for example, I just started paddleboarding, and you're using muscles you're not used to using. There's a lot of balance involved. It would be totally understandable to say, okay, I want to try to get a workout in. Maybe I'll do 2 minutes of hard paddling and then I'll coast for a little bit. And 2 minutes of hard paddling, is my heart rate going to get to 85%? Probably not. But it's still kind of an approach to interval type exercise and a very suitable way to apply it. Now, one thing that's really interesting is we're talking about research questions that are just kind of not fully understood yet. And one of the really interesting things that was observed when high intensity interval training was really embraced by natural bodybuilding, everybody noticed like, damn, this sucks. Like people were doing it during prep as a cardio application, just to kind of burn some calories. And high intensity, especially sprint intensity type work, like maximal sprint type exercise, the sprint interval training application, it can really take it out of you. And there were a lot of people doing this during bodybuilding contest prep, and they just could not recover in time for their resistance training sessions. The total workload, they just felt like they got hit by a truck. I mean, it was just really brutal. And so that's something to keep in mind if you're thinking about incorporating high intensity interval training or sprint interval training. You want to try to balance out that general burden on recovery that is very different than going out for a nice 20-minute jog. You can use it as a tool to get really nice adaptations for cardiorespiratory fitness level. You can burn a ton of calories doing it, but you want to factor in that recovery burden that you're introducing, which does seem to be a little bit disproportionate. And what I mean by that is there was a study by O'Leary and colleagues that I'm going to link in the show notes. What they found was that by doing higher intensity effort that specifically was well above the anaerobic threshold or the lactate threshold, and was creating a great deal of metabolic stress during the exercise bout, they did find some indications that it led to a disproportionate increase in both peripheral and central fatigue measured, right after the bout. And so what's really frustrating is we don't have a lot of great research looking at, I would say, a more ecologically valid model for typical training. Because a lot of times what we're interested in is, okay, I did a really high intensity interval session on Monday. Can I hit legs on Tuesday? Can I hit legs on Wednesday? Should I wait till Thursday?
Yeah.
Or if I put in, 2 of these interval sessions on top of my resistance training, is that going to be it? Am I going to just totally overload my ability to recover effectively throughout the week? So there's not a lot of ecologically valid applied research that helps us make those types of decisions for programming. So HIIT is really tough because anecdotally, it does seem to introduce a very substantial recovery burden. There is some experimental research with low ecological validity indicating or kind of confirming at least glimpses of why that might be the case. But yeah, so if you're going to incorporate this high intensity interval training, I do think it's worth noting that there are a couple studies indicating that for up to 48 hours after a session, you do sometimes see decrements in things like maximal voluntary contraction of the muscles that were being used. Sometimes 48 hours post, you'll still see elevations in things like creatine kinase, like biomarkers of muscle damage. You'll still see some delayed onset muscle soreness at that 48-hour time point. And this is even in people who are doing sport-specific sprint training in the sport that they compete in. So it's not like an untrained person who, touches a weight or does an unaccustomed type of exercise and they're sore for 3 days. Mm-hmm. We're talking about athletes doing sport-specific sprint training and still having some muscle damage and soreness and decrements in muscle force, 48 hours after the bout. So you basically want to keep that in mind. I wish that I could give you a huge volume of research that tells you exactly how to incorporate that throughout the week. A little bit of it is going to be guess and check, but it's something to keep in mind if you start incorporating more high intensity exercise. But But yeah, I think that's pretty much all I wanted to cover here. I do think it's important to acknowledge, if you look at the body comp research for cardio, whether we're talking fat loss or the small gains in lean mass that tend to occur when untrained people take up a cardio modality, the body comp changes for steady state versus interval training seem very similar. So it's not like one is way better than the other. When you look at the concurrent training literature, also, it seems to indicate that they're generally pretty similar in terms of their potential to introduce any type of interference effect. Now, there are mixed findings in that area. You absolutely will find papers saying actually high-intensity interval training is better. You will find some papers where people hint at the idea that maybe it's even worse in terms of concurrent training and interference effects. We've talked about the interference effect ad nauseum, so probably no reason to go back into detail and hit that topic hard. If you go back in the archives, we've talked about it many times. But there is no, whether you're looking at independent effects on body composition or trying to circumvent any potential interference effect, there's really not clear evidence to say that interval training versus steady state, that one is better or worse than the other. These are different tools that can be incorporated. And when it comes to cardio, you got to find something that fits your preferences and can be incorporated into your weekly training schedule without negatively impacting the other things you like to do. In many cases, you should be able to do that with steady state cardio or interval training. And like I said, there are a ton of ways to do interval training.
Sounds good.
All right.
I've got just two more quick notes before the To Play Us Out segment.
Sure.
So the first one, I meant to mention this in my previous segment about my article, and I forgot to. So one very important thing to note is that I think that it may be tempting to listen to everything that I had to say about female subjects being underrepresented in the research and ascribe negative motives to the researchers doing that research. Like I saw the statement several times, like, oh, I didn't realize that exercise science researchers were this sexist. And I understand where that sentiment's coming from. I think that's, I wouldn't feel comfortable ascribing that motive to people. I think what's much more reasonable, or much more likely at least, is that even up to the present day, there's some amount of logistical concern with having mixed sex cohorts, or just with studying female lifters in the first place. So there's concerns that hormonal contraceptive usage could have a notable impact on results, that male and female subjects will have notably different results to a particular intervention, or that testing at different points in the menstrual cycle for your female subjects could add a lot of noise to your data. And all of those things are things researchers want to avoid. Just because, like, if you're adding noise, you need to have a larger effect to be able to detect the signal you're trying to detect. And so there's concern that, like, a lot of the research in our field is kind of underpowered in the first place. That might just increase the risk of false negatives, just harder to get clear results. So I think that's where a lot of trepidation comes from. And I think that now we can more confidently say that those are understandable concerns for people to have had, but based on research that has progressed over the last 20, 30 years, it doesn't, like, those seem to be very understandable concerns that people had that they probably don't need to have anymore. So there have been some metas published in the last couple of years looking at how performance fluctuations across the menstrual cycle look. They tend to be pretty small for most measures of performance. There's now a fair bit of research looking at how contraceptives affect exercise performance, exercise adaptations. Long story short, they don't really seem to have a major difference. Like, they don't seem to make a major difference most of the time. And like I mentioned, now we can look across, close to 40 areas of research, look to see whether studies on male and female cohorts are frequently coming to very different conclusions. They don't seem to be. So it seems like, you can probably use mixed sex cohorts, not really have to worry that much about added logistical hurdles, not have to worry about that much additional noise in your data set, easier time recruiting, more generalizable results, lot of upsides, very few downsides. But it's only become recently, it's only been pretty recent that we can now know with a pretty high degree of confidence that there are pretty small downsides. So I think that's where a lot of it just came from historically. There was the perception that it was basically just easier to study male subjects than female subjects or mixed sex cohorts, just fewer potential confounders in play. And I think it would be very fair to discuss whether that is a good reason for primarily 65% of the time studying male-only cohorts. But, at worst, I think you could say maybe it's laziness. More charitably, you could say that it's, logistical concerns, publish or perish environment. If you can crank out a few more papers a little bit faster with male subjects instead of having to jump through some more logistical hoops, maybe it's just the easier approach. And I wouldn't necessarily count those motives as sexism per se. So I think it's more that stuff than, people just intentionally not wanting to study female cohorts.
Yeah, and I can say I've been involved in many, 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 many discussions planning studies.
Yeah.
And one thing that is really frustrating is that even if you're working with a group of very competent researchers who understand all of those kind of updated perspectives based on research that's happened over the last, 20, 30 years, there is still I think a really pervasive expectation that your reviewers for your paper will not understand that. Yes. So I think a lot of researchers say, I know that oral contraceptives are not going to ruin my study. I know that this is completely viable to be a mixed sex sample for this study. However, I think at least one of my potential reviewers will hold that against me. And for that reason, I won't even try. And like you said, publish or perish. A lot of people are thinking not just how do I answer this question, but how do I answer this question and get it published in the most seamless way possible, the least friction, the least number of battles and quibbles with reviewers. Yeah,
because if you have to resubmit to 4 journals before someone takes it, that's just wasted time that you could be spending any number of other, you could be doing any other number of productive things.
Right. Yeah. So a lot of time, a lot of effort.
Yeah.
And so a lot of people will make this decision, even though they know better, but they think, I don't think everyone else knows better.
Yeah.
And I think a reviewer is going to give me a hard time. And to them, I would say there was a phrase that one of my old stat professors used to use. He was a really funny guy, very snarky and cynical, but he used to always say, because some people would do the same thing in stats. They would say, I have a very nuanced, sophisticated way to approach this, but the reviewers aren't going to get it. So I'm going to use a simpler procedure that is worse, objectively worse for this question. And he would say, give the reviewers a chance to disappoint you. Mm-hmm. And they probably will, but give them the opportunity.
Yeah.
And you might be surprised and find that they actually don't disappoint you.
Yeah. So I just wanted to make sure I got this out. I wanted to make sure I got that out here. I wouldn't want someone to come away from the segment either thinking that just all exercise science researchers are massively sexist, or thinking that I think that exercise science researchers are massively sexist. I think that there are maybe not the best conceivable reasons for things to currently be the way they are, but there are reasons that are at least understandable and not just purely motivated by sexism. So that's one thing I wanted to note. The other thing I wanted to note, just for people in the Facebook group and subreddit, I posted threads asking for questions for a Q&A segment. I did that before I realized how much content we already had on this outline, but those questions will not go to waste. a thing coming up that does not affect you guys at all, but does affect us, is we're currently recording on Mondays. We're going to move to a Friday recording schedule. Maybe next week, maybe a couple weeks from now, regardless. But there's going to be a week where we're recording 2 episodes in a calendar week. And at least one of those episodes, I can guarantee you, will be very Q&A heavy. So those questions will not go to waste. We will address them.
Absolutely. All right, let's wrap it up here. To play us out, we both have some segments. I'm going to start out with a music recommendation. The Black Keys, a well-known band. My buddy Luke got me into the Black Keys, probably like 2007-ish. And then we went to Lollapalooza in 2008, the big music festival in Chicago. And back in 2008, the Black Keys were not a household name. So they actually went on stage at it might have been as early as like 2 or 3 in the afternoon, but they certainly were not a headliner. And they were incredible. And one of the things that really struck me about their live set back in that 07-08 time range is very, very blues heavy. I mean, you still get glimpses in some of their more recent work, but back then the blues influence would hit you over the head, especially when they would play live and kind of riff off of their studio albums. So my music recommendation, of course, is to check out the Black Keys. They're great. They're Buckeyes like me. They're from Ohio, Akron specifically, rubber capital of the world, or so they claim.
Hell yeah.
So Black Keys, great band, great Ohio folks to support. But also, I would encourage people to use the Black Keys as a gateway to a kind of subgenre of music, which is called hill country blues. So this is a very... it's a specific subtype of the blues. Like I said, it's called hill country blues, mostly associated with northern Mississippi. And it's a very rich tradition of blues music. I'll link the Wikipedia in the show notes, but it kind of gives you an idea of what it's like. But a little quote from the Wikipedia: characterized by a strong emphasis on rhythm and percussion, steady guitar riffs, few chord changes, unconventional song structures, and heavy emphasis on the groove, which has been characterized as the hypnotic boogie. So that should be enough to get you interested. Unconventional song structures, like I said, I like a lot of unconventional kind of complexity in my songs, so I think that's why I'm so drawn to it. But a couple great musicians from this hill country blues tradition, Junior Kimbrough and R.L. Burnside, are very well known within this particular genre. And Cedric Burnside, who is the grandson of R.L. Burnside, and I think Cedric's father might have been... There's some relation between Cedric Burnside and Junior Kimbrough's drummer, I believe, but it's this really like localized regional approach to blues music, and everybody played with each other. There was a lot of collaboration, and yeah, it's just really good, really authentic blues. And the fun thing is when you start reading into their biographical content about all these musicians, they are all like mythical people, like the way that they approach music and life, like it was just such a, like when you read into some of these big characters within the genre, they're just like larger than life personalities. So yeah, it's a very rich blues tradition, and musically it's just excellent. So check it out.
Very nice. I have a far more basic media recommendation, probably not quite as cultured. But my wife and I are currently playing through the most recent entry into the Pokémon canon, Pokémon Legends Arceus. And I gotta say, it's been a blast so far. If you enjoyed playing Pokemon games for Game Boy when you were young, and at some point you just kind of burned out, you're like, okay, I've played the same game 10 times at this point. It's all the same. You pick a starter, you beat some gym leaders, you beat the Elite Four, throw the Master Ball at a legendary Pokemon, and boom, you're done. If you got kind of tired of that formula, Pokemon Legends Arceus still contains the core Pokemon DNA while being a very welcome change of pace. So it takes place like hundreds or thousands of years before the main Pokemon story, when people are just coming in contact with and learning about Pokemon initially. And so you're playing as essentially a researcher who's going around and trying to catch and study the Pokemon. There's not like the same gym leader type structure. And I would say the moment-to-moment gameplay is far more engaging because it's not like a fully open world, but it's kind of like a semi-open world concept. Like you go to particular areas, you can move around freely, and instead of just a Pokemon jumping out at you from the wild grass, you can see them like they're all there. They're walking around, kind of like the big kind of central hub area in Sword and Shield, but they'll actually like attack your character. So, you're not just walking around in tall grass waiting to be attacked, like for grinding for levels. You're like actively trying to avoid Pokemon who are trying to attack you, the player, not just like your Pokemon. And also like when you're trying to catch certain ones, like some are skittish, and so you have to sneak up on them. So there's a bit of a stealth element. You have to dodge attacks with a dodge like roll mechanic that's very similar to Dark Souls, which I find very funny. But yeah, it's a fun game. Like there's definitely some. There are some ways that it doesn't quite work, which makes sense. Like it's a relatively large departure from a series of games that had been very formulaic for a long time. So it's not perfectly polished. But if you have ever enjoyed a Pokemon game, I think it's worth checking out. It's a lot of fun.
All right, good stuff. I don't want to brag, but back in the day on the Game Boy version of Pokemon, I had a pretty special lineup. I really cleaned up. So I don't know if I'm going to give this one a try, but hopefully some people will.
Good deal.
All right, that does it for this episode. As always, thank you for listening, and we'll be back next week with another. Thank you for listening to the Stronger by Science podcast. If you enjoyed the podcast, be sure to sign up for our free newsletter to get concise breakdowns of relevant research, as well as 28 free training programs for all skill levels and all schedules. We hate spam just as much as you do, so we'll only email you when we have something really interesting to share with you. You can sign up for the free newsletter at strongerbyscience.com/newsletter, or just go to the Stronger by Science homepage and click the free programs button at the top. If you want to join in on the Stronger by Science podcast conversation, be sure to check out our Facebook group and our subreddit. The links for both are provided in the description of today's episode. Finally, please remember that we are not medical doctors or registered dietitians. So, before you make any changes to your exercise or nutrition habits, be sure to check with a qualified healthcare professional. Once again, thank you for listening, and we will be back soon with another episode of the Stronger by Science podcast.